Hey everyone, welcome back, and today we'll be working on the factorial stretch. Before we start working on a couple of problems, why don't we look at the definition at the top? The notation n factorial is defined as n factorial is n times n minus 1 times n minus 2 times all the way until you go to 1. So, for example, we can say 4 factorial is 4 times 3 times 2 times 1. When you multiply that all out, you get 24. So now let's go ahead and look at a couple of these problems. First off, number 15. If n is a positive integer and n plus 1 factorial minus n factorial is less than n cubed, what is the greatest possible value of n? So looking at this problem, we have n factorial, and we know n plus 1 factorial can be rewritten as n plus 1 times n factorial, which is really handy because this will allow us to factorize. So we get n factorial multiplied by n plus 1 from the n plus 1 factorial minus 1 is less than n cubed. This gives us n factorial times n is less than n cubed. Simplifying to n factorial is less than n squared. Let's read the problem. We want the greatest possible value for n. And so we can go ahead and try a couple of the smaller values to see if we can find that pretty quickly. So first, if we try n is 1, we get 1 is less than 1. This doesn't work, so we'll move on to the next one. N is 2. 2 less than 4 works. This could be the answer, but we also need to check for n is 3. 6 is less than 9. Again, that works. And then finally, we have n is 4, which is 24 less than 16. This here is not true. So that means the largest, and after that, we note that n is 5 becomes 120 and 25. And this starts increasing much faster than the square. So that means we note that the answer must be n is equal to 3. The next problem we'll look at together is question 20. How many positive integers, n less than equal to 25, are there for which n factorial is a factor of n factorial? So basically, we need n factorial over n squared to be an integer. So we can start looking at some special types of numbers. So we first off look at prime numbers. So a reminder for prime numbers are simple numbers that are only divisible by 1 and themselves. So for example, 2 is divisible by only 2 and 1 and no other number, so it'll be prime. Now the trick here is that when we do n factorial, p factorial actually, over p squared for some prime number, we get p minus 1 factorial over p. And since p is only divisible by 1 and itself, that means that in any of these numbers over here, there won't be the prime number p. So this cannot be an integer. So we can get rid of all the prime numbers in this list, which include 2, 3, 5, 7, 11, 13, 17, 19, 23, and that's it. So now we're left with all of these numbers. Now, after here, the main way to go through these is to eliminate other numbers as well by going through them all. Instead of going through all here, you can check them all on your own. The only number that actually turns out to not work is 4, which means the number of numbers that remain is the answer, and therefore our answer is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And that is the answer. Thank you all for watching. I'll see you guys in the next video.